For this problem, I'll start by getting into the standard form of y double prime plus p of x times y prime plus q of x times y is equal to 0. To do this, I'll divide all the terms by x squared. We'll have y double prime minus x over x squared times y prime plus 2 over x squared times y is equal to 0. These x's will cancel. We'll be left with y double prime minus 1 over x times y prime plus 2 over x squared times y is equal to 0. The coefficient of y prime is negative 1 over x, so we know p of x is going to be equal to negative 1 over x. We can now use the reduction of order formula. Y2 is equal to y1 times the integral of e to the power of the negative integral of p of x dx over y1 squared. Y1 was given as x times sine of ln x. I can substitute that into this equation. Y2 will be equal to x sine of ln x times the integral of e to the power of the negative integral of negative 1 over x dx over x sine of ln x. All of that will be squared. This numerator will be e to the power of the integral of 1 over x dx, which will be e to the ln x, which is just x. I can rewrite this. Will be equal to x sine of ln x times the integral of x over x squared times sine squared of ln x. These x's will cancel. This integral will become the integral of 1 over x times sine squared of ln x. We can use u substitution to solve. U will be equal to ln x, so du is going to be equal to 1 over x dx. This integral will become the integral of 1 over sine squared u du, which will become the integral of cosecant squared u du. So this will become negative cotangent u. So y2 will be equal to x sine of ln x times negative cotangent of ln x. We can write negative cotangent of ln x as the negative cosine ln x over sine ln x. We can multiply that by x sine of ln x. The sine ln x terms will cancel. So y2 will be equal to negative x times cosine of ln x, because we'll end up writing this in the form y equals c1 times y1 plus c2 times y2. It doesn't matter if y2 is going to be positive or negative. That'll be accounted for with the constant. So y2 will just be equal to x cosine of ln x. And that is our final answer. If this video helped you, consider subscribing.